Okay, recording is rolling. So welcome to Monday. We're gonna continue with the quantum journals, pick up where we left off last week. Give you guys a quick recap before we go into the next topics there. Uh, Before we do that, though, there are going to be some relocations this week. You guys know that this week is the first week of AP exams. AP exams are also next week. I bet a bunch of you guys are taking AP exams. Some students in this room looks like they're taking the government one right now. There's also an end of course exam for biology on Thursday, which I'm going to proctor in this room, so that's why it's relevant. Anyway, all right, let's look at relocations. So I'm making a video for all my classes. So if you're watching this video at home, or if you're in my room, you can figure out which class you're in and where you're going. Right. So this is Wednesday the 3rd. Now my first 4 classes are being relocated. Right, 5th, 6th, and 7th I'll have in here, but my first 4 classes are being relocated. Right. So you guys know where you're going on Wednesday? You guys know where you're going Wednesday? Okay, because you're not going to be here, right? All right, and then Thursday there are also relocations. So similar deal. Right, here's the Thursday story. Okay, so first 4 classes relocated. Right. I will post these probably like out in the hall on my door. Right. I think Thursday is the one that I'm going to be proctoring in this room. So, okay. So you guys know where you're going Wednesday, Thursday? Right. Guys, all right. So quantum journals. No, it's been a long weekend. Let me remind you guys some of the last things that. Well, here let's do a broad thing, right? Okay. So we're looking at how small is an atom. This photoelectric effect, Heinrich Hertz, 1887, explained by Einstein in 1905. Some of the evidence that maybe light had this dual nature. We're looking at Planck's constant. Uh, uh, De Broglie comes along and says, hey, I think a lot of particles have this dual nature of wave particle duality, right? Including electrons, which explains chemistry. And we looked at one chemical property like transparent glass. We're looking at particles exist probabilistically. Even to say a particle is really kind of deceiving, right? Because like at the macroscopic level, you can have like, right, we got a baseball, it has this mass, this position, this velocity, but in particle physics, well, things exist kind of spread out until you measure them, and then that wave function, the Schrodinger wave function, collapses to one reality. Right? Look at Heisenberg uncertainty principle. There's like there's a limit to your knowledge as to how precisely you can know where a particle is and its momentum. Right, you run up against this limit that's built into the fabric of the universe. Okay? This double slit experiment. This was a weird one. So, is an electron or a photon or any small particle more like a particle or a wave? But well, if you run this classic double slit experiment, you might get like a wave outcome. But if you have some kind of detection device, it actually changes the nature of that particle. And it actually turns back to more, well, acting more like a like a point mass. Right? Uh, Schrodinger had this thought experiment that connected the quantum world to the macroscopic world. So what if there was this entangled particle, and by undergoing a radioactive decay, which is probabilistic, that would trigger this process that might affect something macroscopic, like a cat. He's trying to poke holes in these ideas at the time, but this one stuck around. It's like, actually, there's something interesting to that, right? Now, this would be a closed box where the outside observer can't detect inside the box at all. So, kind of you can't really do this experiment, right? So it's just a thought experiment. Quantum Zeno effect, similar thing. A particle physicist, if you have some kind of detector on a radioactive particle, then it just won't decay because it keeps collapsing back to its original state. All right, that's going to bring us to quantum tunneling. All right, you guys ready for quantum tunneling? All right, so let me switch my screen over and I learned that one.